Hello friends, this is Rashmi Singh and welcome to my channel Unraveling Science. Today's topic is Gravitation, Class 9, Chapter 9. Have you ever wondered why does a ball when dropped always fall down on earth? Or why does moon always revolves around the earth? It's because of the force of attraction of the earth. Every object in universe attract each other with a force, and this force is called gravitational force. Are gravity and gravitational force same? Gravitational force means force of attraction between any two bodies, whereas gravity means force of attraction between earth and any other object. So, gravitational force is exerted by all the objects, but gravity is exerted only by the earth. We all know that when an apple fell on the Newton's head, he discovered gravity. If earth attracts apple, can an apple also attract the earth? Yes, an apple can also attract the earth as per Newton's third law of motion, which says every action has an equal and opposite reaction. But the mass of the earth is much larger than the mass of the apple, hence force applied by the apple appears negligible with respect to the force applied by the earth. Newton's universal law of gravitation. Isaac Newton in 1687 proposed universal law of gravitation, according to which every mass in this universe attracts every other mass with the force which is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them. As you can see here, the figure given depicts the force of attraction between two objects with masses m1 and m2 respectively, and the distance between them is d. So, force is directly proportional to the product of the masses m1 and m2 and inversely proportional to the square of the distance between them. So, we can write force is equals to g m1 into m2 upon d square, where g is a constant and known as gravitational constant. The value of g is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Importance of universal law of gravitation. Universal law of gravitation successfully explains several phenomena like the force that binds us to the earth, the motion of moon around the earth, the motion of planets around the sun, and the tides due to the moon and the sun. All the objects moving in circular motion keep on changing its direction. A force called centripetal force acts upon the object that keeps it moving in a circular path. The centripetal force is exerted towards the center of the circular path. So as you can see here, the centripetal force is because of the gravitational force. That's why moon revolves around the earth and all the planets revolves around the sun. Free fall of an object and acceleration due to gravity. When an object is thrown upwards, it reaches a certain height and then it starts falling down towards the earth. It is because of the earth's gravitational force which is exerted on it. This fall under the influence of earth is called free fall of an object. During this free fall, the direction do not change but the velocity continuously changes. The uniform acceleration produced in a free falling object due to the gravitational force of earth is called acceleration due to gravity. Its unit is same as the acceleration, which is meter per second square, and it is represented by small g, and it is always act toward the center of the earth. Calculation of acceleration due to gravity. Let the mass of an object on the surface of the earth is m, small m. Mass of earth is capital M. Distance between the earth and the object is equals to the radius of the earth, which is r, as is shown in the picture. Now we know that gravitational force is equals to g, product of the masses, and upon the distance between them, that is square of the radius. Also, force of any object is given by mass into acceleration. So now this force is equals to the gravitational force. So we can write g m into m upon r square is equals to ma. Now cancelling the small m, we get acceleration is equals to g capital M upon r square. Now we put the values of g, m and r in the given equation. So we'll get, solving these equations, you can pause the video and see the calculations here. Acceleration due to gravity is 9.8 meter per second square. Hence, this is acceleration produced by the Earth's gravitational force, and all this is always constant. Relation between gravitational constant and acceleration due to gravity. G is equals to capital G m upon r square. We know the three equations of motion. V is equals to u plus at, S is equals to ut plus half at square, and v square is equals to u square plus 2as. Here u is the initial velocity, v is the final velocity, a is the acceleration, t is the time, and s is the distance. Now, since the acceleration a is acceleration due to gravity, which is g, so a is replaced by g. Also, the distance in this case will become height, so s will be replaced by h. So, the new equations will be now v is equals to u plus gt, h is equals to ut plus half gt square, and v square is equals to u square plus 2ah. Now, to solve the questions, we must remember, if a body is falling downwards, initial velocity is 0, acceleration due to gravity is plus 9.8 meter per second square. When a body is thrown upward, final velocity is equals to velocity at the highest point. Acceleration due to gravity here is minus 9.8 meter per second square. Difference between gravitational constant and acceleration due to gravity. So, gravitational constant's value is 6.67 into 10 to the power minus 11 Newton meter square upon kg square, whereas acceleration due to gravity value is 9.8 meter per second square. Capital G is always constant. Small g is changes according to the direction. Capital G is a scalar quantity, smaller g is vector quantity. Mass. Mass is defined as the quantity of matter in an object. Mass is a scalar quantity which has only magnitude but no direction. Mass of a body is constant and does not change from place to place. Mass of a body cannot be zero. Weight. The force with which an object is attracted towards the center of the earth is called the weight of the object. So, force is equals to mass into acceleration, that we know. In case of earth, A is g, that is acceleration is acceleration due to gravity. So, we can write F is equals to m into g. But the force of attraction of earth on an object is called weight. So, we can write weight is equals to m into g. Now, weight is the force and its SI unit is Newton, and it depends on the acceleration due to gravity, and it is a vector quantity. Weight of the body on moon. Now, mass of the earth is 100 times that of moon, and the radius of the earth is 4 times that of moon. So the mass of object is small m, mass of earth is me, radius of earth re, mass of moon mm, and radius of moon is rm. Now given the mass of the earth is 100 times that of moon, so we can write mass of E is equals to 100 multiplied by mass of moon, and the radius of earth is 4 times that of a moon. So we can write radius of earth is 4 times the radius of moon. Now weight of the earth will be WE, that can be written as GME into M RE square. Weight of moon similarly is Wm, which can be written as GMM small m upon Rm square. Now weight of the moon upon weight of the earth will be weight of the moon divided by weight of the earth. Solving these equations, you can pause the video to see the equation. We get, putting the values of ME and RE in the given equation, we get the ratio of 1:6. What does this shows? This shows that the weight of the moon is 1/6 of the weight of the earth. Thrust and pressure. Thrust is the force which is acting on an object perpendicular to the surface. It means that thrust is always perpendicular to the surface on which the force is applied. For example, as you can see here in the picture, when you stand on the loose sand, the force, which is the weight of the body, is acting on the area of the sand equal to the area of your feet. But when you lie down, the same force acts on the area equal to the contact area of whole body with the sand, which is larger than the area of your feet. Thus, the effect of force of same magnitude on different areas are different. Therefore, the effect of thrust depends on the area on which it acts. The thrust on unit area is called pressure. So, we can say that pressure is equals to thrust upon area. And the SI unit of pressure is Newton per meter square. In the honor of scientist Blaise Pascal, the SI unit of pressure is also called Pascal or PA. The pressure is inversely proportional to area. As the area increases, pressure decreases and vice versa. Solids exert pressure on the surface because of their weight. And fluids like gases and liquids, they also have weight. Therefore, they exert pressure on the surface and the walls of the container in which they are put in. Buoyancy. Whenever an object is immersed in a liquid, the liquid exerts a buoyant force or upthrust in the opposite direction of the gravitational force. This is called force of buoyancy. It depends on the density of the fluid. As you can see here, an object is able to float in the water when the gravitational force is less than the buoyant force. And the object sinks in the water when the gravitational force is larger than the buoyant force. Why does an object sink or float on water? An object can sink or float on water based on its density with respect to the water. The density is defined as mass per unit volume. Objects having density less than water float in it, like cork floats in water. And objects having density more than water sinks in it. For example, iron nail sinks in the water. Thus, buoyancy depends upon the density of the liquid, the volume of the object. As the volume increases, density decreases and vice versa. Archimedes' principle. According to this principle, whenever an object is immersed in a liquid, fully or partially, the liquid exerts an upward force upon the object. The amount of that force is equal to the weight of the liquid displaced by the object. As you can see here in the picture, when the liquid is immersed, it displaces water. So here the weight of the object is 2 kg, so it displaces 2 kgs of water. Application of Archimedes' principle. It helps in evaluating relative density. What is relative density? It is the ratio of density of substance to the density of water. Second, it is used in designing ships and submarines, and it is used in making lactometers and hydrometers. Thanks for watching. Please do like, share and subscribe.